Okay, so here is a series of questions to find different properties of rational functions. So if the property doesn't exist, write none. And our first function is the numerator is 2x plus 3 and the denominator is x minus 1. So let's see, to find the x-intercept, that means that we want to set r to 0 and solve. So we're going to look for the, basically set the numerator, well, if we assume that the function is fx equals nx over dx, a numerator polynomial and denominator polynomial, the x-intercept would be found by looking at nx equals 0, assuming that there's no common factors. So that means we're going to set 2x plus 3 equals 0. So that means that x is going to be, let's see, 2x equals minus 3. So x is equal to minus 3 halves. For the y-intercept, we want to set x equal to 0 and solve for y. So we're going to set x equal to 0 and solve for y. And in this case, we would have, so we're going to have 0 plus 3 divided by 0 minus 1 or minus 3. So that's our y-intercept. There are no holes because we're going to be looking for common factors. So this would be looking for common factors. So there's none. Vertical asymptotes are where the dx is going to be 0 and there's no hole. So we're going to consider when dx is equal to 0, the denominator. So that means that x minus 1 equals 0 or x equals 1 will be the equation for the vertical asymptote. A horizontal asymptote occurs when the leading terms either have the same degree or the denominator term, leading term, has a higher degree. So let's see, in this case, our leading terms compared are 2x divided by x. So that means that our horizontal asymptote is going to have an equation of y equals 2, the ratio of the leading terms. And when you have a slant asymptote, you do not have, when you have a horizontal asymptote, you'll have no slant asymptotes. So none. Okay, let's look at the next one. So this polynomial, we have to do a little bit more work because I want to factor it. So we're going to go down to, let's say we'll factor it here. So for 2, this is the work. So for 2, we're going to have x minus 1 divided by, and let's see, the denominator factors as x, looks like plus 6 and x minus 1. So that gives us our denominator up here. And then that means that we have a common factor of x minus 1. So this will be 1 over x plus 6 as long as x is not equal to negative 1. So our x-intercepts, look at the numerator and see where it's equal to 0, but also defined. So there's not going to be any x-intercepts. Our y-intercept, we can look at the reduced form, which is this form right here, and we can set x equal to 0. So we're going to have 1 over 0 plus 6, or just 1/6. So that means that we'll have a y-intercept of 0, 1/6. Holes. So we do have a hole because we do have this common factor of x minus 1 in the numerator and also the denominator. So that means that we have a whole at, at x equals 1. And then to find the y-coordinate for the whole, we're going to replace look at the reduced function and replace the x with 1. So the y-coordinate is going to be equal to 1 over 1 plus 6, or 1/7. So our coordinate of our whole is 1 comma 1/7. Vertical asymptote for problem 2. Well, there we want to look at when dx is equal to 0 and there's no holes. So that's going to be the situation when, x plus 6 is 0, or x equals minus 6. That's our vertical asymptote. Horizontal asymptotes, we want to look at the two leading terms, so we're going to look at x over x squared. In this case, the degree in the bottom is larger than the degree in the top, so 2 is greater than 1, which means that we're going to have a horizontal asymptote at y equals 0, so we'll have no slant asymptotes. Okay, so for problem 3, looks like we're going to need to factor that one too, so I'm going to draw a little asterisk. We need to go factor that. So let's see, blue. So for 3, let's go ahead and factor the numerator. So let's see, negative 12 would be negative 6 times 2. So we'll have x minus 6 times x plus 2 in the numerator, and in the denominator we have x minus 3. So none of the factors cancel. And let's see, it looks like we're going to have a slant asymptote there. So let's see, x-intercept. So we set the numerator equal to 0. So the numerator is going to be 0 when either x minus 6 is 0 or x plus 2 is 0. So we're going to have 2 x-intercepts at x equals 6 and also negative 2. Let's see, the y-intercept was set x equal to 0. So that's more easily looked at when you look at the expanded form. So we're going to have 0 plus 0 minus 12 divided by 0 minus 3. So the y-intercept is going to be y equals 4. Holes, there are no holes because there's no common factor. Vertical asymptotes, let's see, for problem 3, vertical asymptotes are going to be when the denominator is 0, so that would be when x minus 3 is 0. So the equation for the vertical asymptote is x equals 3. We're going to look at the leading terms to look at either a horizontal or a slant asymptote. So there's no horizontal asymptotes, but there is a slant asymptote. So to find the equation for the slant asymptote, we need to do some polynomial division. And if we do that, we would find out that the slant asymptote has an equation of y equals x minus 1. Okay, so in problem 4, x-intercept, so when is the numerator equal to 0? And it's never equal to 0. If we set x equal to 0, it looks like we'll have minus 2 divided by 0 minus 3 quantity squared. So that looks like it's minus 2 divided by 9. So our y-intercept will be 0 comma minus 2/9. There are not going to be any holes because there's no common factor. A vertical asymptote is going to occur when the denominator is 0 and there's no holes, and that is going to happen when x minus 3 is 0 or x equals 3. And then the horizontal asymptote, let's see, in this case we're going to be looking at the leading term in the top and the leading term in the bottom, which would be x squared. So since in this case the degree of the bottom polynomial is bigger than the degree of the top polynomial, meaning 2 is greater than 0, we're going to have a horizontal asymptote of y equals 0, and we'll have no slant asymptotes. Okay, for problem 5, that also looks like we're going to need to factor, so let's go down here. And let's see, so problem 5, how does that factor? So the numerator factors into, let's see, looks like x plus 3 times x minus 1 in the top, and then in the bottom it's going to factor as x minus 3 times x plus 1. Okay, so 5, that's how that factors, and there's no common factors, so that means that we're going to have no holes. The x-intercepts are going to occur when the numerator is 0, so that means when either x is equal to minus 3 or 1. And the y-intercepts are going to be when x is 0. So let's see. Again, it's easier to look at expanded form. So we're going to have 0 plus 0 minus 3 divided by 0 minus 0 minus 3. So that's going to be 1. So our y-intercept will be 0, comma 1. Vertical asymptotes occur when the denominator is 0. So that's, looking down here, it looks like we're going to have x equals 3 or x equals minus 1. X equals 3 or minus 1. And then horizontal asymptotes, let's see, the degree in the top, leading term is x squared, degree in the bottom is 2, x squared. So our horizontal asymptote is going to be y equals 1, and we have no slant asymptotes. Okay, the last one, it looks like that is something we need to factor too. So for problem 6, factorization is x plus 3 times x minus 2 divided by, let's see, we can factor out an x in the bottom, and we're left with x squared minus 4. That's a difference of squares, so that factors some more. X plus 3 quantity times x minus 2 quantity divided by x times x plus 2 x minus 2. Okay, and this looks like there's a common factor, so we are going to have a hole. Might as well find our hole right now. So the hole is going to occur when x is equal to 2. And the y-coordinates for our hole, let's see, so we're going to use this reduced part right here, okay, and we're going to plug in x equals 2, so we'll have minus 2 plus 3 divided by, did I say minus 2? I meant 2, so plus 2 plus 3, and then 2 times 2 plus 2, so that looks like we have 5 in the numerator and 4 times 2 are 8 in the denominator. So getting back up here to our whole coordinates, we're going to have 2, 5, 8 as the coordinates of our whole. Okay, I'm back here. X-intercepts for problem 6. So that's when the numerator is 0 and there's not a whole. So that means we're going to look at x plus 3. So x equals minus 3. And for the y-intercept, we're going to set x equal to 0. And let's see, when x is 0, the function is going to be undefined, so there's none. And then for vertical asymptotes, that's why there's no y-intercept, because there's a vertical asymptote. Our vertical asymptotes are going to be when the denominator of the reduced fraction is 0, so we're going to have x equals 0 and also x equals minus 2. The horizontal asymptotes, we're going to look at the leading term in the top, ratio of that divided by the leading term in the bottom. And because 3 is greater than 2, the equation for the horizontal asymptote will be y equals 0, and there are no slant asymptotes. Okay, so in the last problem we want to write, and we're going to flip up here. In our last problem we're going to write an equation in factored form for the rational function shown. Okay. So let's see, this number 7 looks like there's no holes, but it looks like we're going to have a horizontal asymptote at y equals 2, and we have a vertical asymptote at x equals 1. So our function, call it r of x, okay. We'll have a factor of x minus 1 in the bottom. We need the same same degree in the top. So let's say, we also need a y-axis intercept at 0, 1. So the y-axis would mean when x is 0, we need a 1. So we could do, let's see, x minus a half times 2. And does that give us our y-axis intercept? So that will be when x is 0, we're going to have 1 in the top, or minus 1 in the top and a minus 1 in the bottom. So yes, so we have r of 0 is equal to 2 times 0 minus a half divided by 0 minus a half, or minus 1 divided by minus 1, which is 1, so that checks. So that could be our rational function for that. And then for the second problem, it looks like we have a horizontal asymptote of y equals minus 1, a vertical asymptote at x equals 2, and then also notice that we have a hole at, looks like 1, 2. Okay, that's our hole there, indicated by that open dot. So probably want to start with something that looks like x equals, okay. So vertical asymptote means that we're going to have this factor of x minus 2 in the bottom. A hole at x equals 1 means we have x minus 1 in the top and x minus 1 in the bottom. We need to have the same degree, and we also need to have a a point of 3 comma 0 in top, so that means that we could have x minus 3 in the numerator. Okay, we're almost set. Oh, I meant to say -2. Her hole's at, where's our hole? Oh no, our hole's at 1, -2. We also need a horizontal asymptote at y equals -1. So we need to add a negative out here so that the leading term is negative. Leading term is going to be -x squared divided by x squared. That works. And then we could check the coordinates of our hole. So let's check using the reduced reduced function of -x minus 3 divided by x minus 2. Let's check that we have at x equals 1. We're going to have -1 minus 3 divided by 1 minus 2. That's going to give us -2 divided by 1. So yes, that does give us -2. So that would be our hole. Okay, that's all for right now.